Okay, hello. So I will present to you Andrey Markov. So Andrey Markov, first of all, he's born in Russia. He's a Russian mathematician. He's born in 1856 in the city of Ryazan. He died in 1922 at the age of 66. He moved to St. Petersburg when he was young. Right before he moved to St. Petersburg, Markov was very ill. He had health problems basically, and he couldn't walk until 10 years old. And even though he had to walk with crutches, after that, though, it was fine. And when he moved in St. Petersburg, it was because his dad had a job over there. Basically, afterwards, when he was only 17, first of all, when he arrived in St. Petersburg, he started going to school for the first time. At only 17 years old, he was very interested by mathematics to a point where he found a new way to solve linear differential equations, and he talked to his teacher. He then wrote a letter to university teachers, and he later on joined the club of one of his professors who taught him basically at the University of St. Petersburg, which is the next slide. So he attended this university and acquired his master in 1878 with the gold medal. It was attributed to the student that basically had the best essay out of everyone in the subject. So out of all the students who followed his class, he won the gold medal, which is pretty impressive. He then started to teach at the University of St. Petersburg, and he acquired his doctorate 2 years later. By the way, the master was equal to a doctorate today, and right now the doctorate is equal to, I think it's something called habilitation. So yes, after that he decided to teach. So starting in 1878 up until 1905, he taught during these years, and after that he retired. We'll see that he didn't completely retire. He was influenced by the left wing in politics. Now we should know that at that time was the Tsar regime until 1917. 1917 was the Bolshevik Revolution with Lenin, and basically which was the take of the power from the left wing's politicians, and he was greatly influenced by them. He supported them even to a point that at sometime in the early 20th century, I think it was 1903, a professor at the university actually was kicked out and arrested because he was accused of being too left wing, and he opposed to that, the Markov, and decided that year he received few awards from the Tsars. He decided to actually deny these awards because he didn't to be loyal, because he was so angry about the Tsars. And there was also a few other episodes of him basically going against the Tsars, but he was never arrested because he was considered too much of an academician, and they didn't want to put him to jail. He came back after, I skipped the point. So in 1917, he asked to go to a very poor city where he taught mathematics at secondary level without remuneration. So basically at the Bolshevik Revolution, there was a famine and no food for people to eat. So he decided to go there, no remuneration, and basically teach the children mathematics since he was so good at it. He came back to St. Petersburg unhealthy and died a few years later, unfortunately. He came back very ill, and he always lived pretty much always ill. So yeah, basically this is the part where it's more interesting on what exactly he touched during his life, the main subjects he actually worked with. So there was the number theory of an analysis, which basically is related to the study of integrals. We'll see that he mainly worked with integrals, which is quite interesting. So number theory and analysis, study of integers, the algebraic continued functions, which is a bit like the number theory and analysis, as we see here in the image. I will click on it right now. We did see this last semester with Monsieur Saint-Amand. We saw it. It's not exactly the same thing. We didn't see it as precisely as it is, but I did a couple of research, and it goes hand in hand with the Gauss-Jordan, one of the Gauss-Jordan theorems. So it's linked to that. So that's interesting. It goes to with our course a bit. I don't think we have seen this. So there's also the limits of integrals. Oh yes, I forgot to say the algebraic continued fractions. It's basically, as we see here, it's a sum of the integers. So it's always like you find the integral and then you have to sum. So we saw that with Monsieur Harvey as well. So yes, the limit of integrals, which we saw that last semester as well. That's why we know a bit about Markov. We actually heard his name last semester as well. The approximation theory, basically, this is how functions vary. So it's like a study of functions, if you want. The convergence of the series, which is a bit the same. We saw this as well last semester, the convergence of the series. And finally, sequences of mutually dependent variables. It's a bit like approximation, but more comparing to real life elements like economy, physics, and stuff like that. It's quite interesting as well. It's very big graphs or plan cartésien, and with variations, and you basically study these variations. The Markov chain, which is his biggest work, the Markov chain was invented by Markov. This is why it's called Markov chain. It allows basically to predict the importance of a shares of a company over a long period of time. Sales of items. It's useful also in economics, physics, and many more. So to find the Markov chain, it allows us to basically know the steady state, and it's a long-term behavior of a market, for example. So it helps us knowing when the market will stabilize, basically. To find a steady state, we have to multiply the probability vector with the transition matrix. So W is the steady state. That the small w afterwards is going to be the probability vector with the transition matrix, which is the P. And with a linear system, we can then find when the market stabilizes with two different ways. I personally prefer replacing all with the ones the first row. And finally, as a small conclusion, this is one of the most influent work done by Markov, the Markov chain, and was attributed many awards when he developed this system. We saw that at 17 years old, he already viewed a way to actually do linear system more efficiently. He was a great benefit to economics, physics, science, and many more subjects. With all the mathematical fields he has touched, Markov was able to make a name for himself in this domain from which he will always be remembered. So, thank you.